In this video, I'll give you a complete roadmap to becoming a machine learning engineer in 2026. This will break down all of the core topics that you need to understand, the order in which you should learn them, and only go over things that are absolutely essential so you don't waste your time on topics that do not matter. With that said, let's get into it. Okay, so I'd like to start by just defining what a machine learning engineer is, and then we'll get into the roadmap. Now, machine learning engineer is simply a software engineer that spends a majority of their time working on machine learning related features and software. Now, that doesn't mean that they don't do any normal software engineering work. In fact, a lot of machine learning engineers find themselves doing a lot of traditional software engineering work, especially as it relates to deployments, testing, continuous integration, and collecting large amounts of data. So while as a machine learning engineer, you do need to know machine learning itself, and you will be building machine learning models and AI, it doesn't mean that's everything that you're doing, so just keep that in mind. Now, a few interesting stats about machine learning engineers, and then we'll get into the roadmap. First, the demand for ML engineers in the United States grew roughly 35% from 2023 to 2024, and has continued to grow in 2025, indicating a very fast-growing field. And job postings across places like Indeed, LinkedIn, and other specialized job boards shows that ML engineer consistently ranks as one of the top 3 fastest growing technical roles in 2024 and 2025. Now, all of that to say that this is a very fast-growing, emerging field. A lot of companies are hiring machine learning engineers right now, and as someone who's helped many people land those types of roles, I can say honestly that not many developers are actually qualified, and companies have a hard time finding good machine learning engineers. I would bet that if you became a machine learning engineer or started getting into that now, you would have a more prosperous career than like a front-end developer or a back-end developer. So it's definitely something worth investing in. And while it can be a little bit more challenging, I think that it definitely will pay off in the long run. With that said, let's get into the roadmap and discuss how to become an ML engineer. Okay, so first topic on my roadmap is going to be core Python skills. While there are some other languages that are used for machine learning, in 95% of situations, you'll be writing code in Python. You will typically be doing scripting in Python, data handling and wrangling, and writing your models and all of the configuration for them in Python code. That means you need to be very good at Python, so before you even look into any machine learning topics, get good at that. That's if statements, for loops, variables, functions, classes, object-oriented programming, more advanced features like decorators, generators, list comprehensions. Essentially, you need to be good at the Python programming language and able to write code in Python confidently before you start getting into all of the ML stuff. I would recommend spending at least 1 month here, to be honest, probably more like 2, to really become comfortable in the Python language and write normal Python code, scripts, games, etc., mini projects before moving forward. Now, once you've gotten comfortable with Python, the next topic on my list is going to be computer science fundamentals. Here, I'm talking about time complexity analysis, so things like big O notation, as well as data structures and algorithms, and then threading and concurrency. Now, while this is not the most important topic in the world, as an ML engineer, you likely will still have to pass data structures and algorithms style interview questions, especially at large tech companies. And these are fundamental concepts that actually do apply and show up in ML engineering. So understanding them is, well, just kind of essential and very valuable. So I'm talking about learning things like arrays, hashing, two-pointers, linked lists, trees, dynamic programming. All of these features or all of these algorithms or data structures are useful to know and solidify that computer science knowledge, which I think is very helpful as an ML engineer. Again, I would recommend spending about 1 month learning these topics, really being comfortable with them, reproducing some of the algorithms yourself, and more importantly, not memorizing, but understanding the relative efficiency of the different data structures and when to use which. So continuing past that, I have software engineer tools. Now, no matter what type of software engineer you are, these are core tools that you'll need to understand. First, we have version control, so essentially Git and GitHub. Then we have Bash or Linux commands. In a lot of situations, you'll be working on a virtual private server or in a scripting environment where you won't have access to a graphical user interface. So understanding those commands and how to navigate a Linux file system is pretty much essential. And then lastly, having mastery of your IDE, so whatever editors that you're using, having some debugging skills, and also the ability to use things like Jupyter notebooks, for example. A lot of times as a machine learning engineer, you will be writing scripts, not massive programs, but the better you are in these tools, the better off you will be, and you should invest some time to really learn them well. Moving on, the next topic on my list is data handling. Now, as a machine learning engineer, data is the most important thing that you will work with, collect, use, clean, etc., and you really need to be quite good at working with data. If you have poor data, you are going to have poor models, and a lot of people skip through this section not realizing how important it is. So ensure that you learn the following before you even start getting into dealing with any machine learning models, and that's going to be NumPy, Pandas, Matplotlib, Seaborn, and then some techniques within those different modules. So what I just listed are 4 Python modules that are all used for data handling and analysis and are absolutely fundamental to pretty much everything you do within Python machine learning. For example, NumPy is a scientific computing module, Pandas is used for loading in large amounts of data and dealing with data sets, and Seaborn and Matplotlib are data visualization libraries, which you need to understand to be able to actually view your data and see what is going on. Now, you also want to understand data cleaning, data pre-processing, and data batching. Essentially, how do you collect and deal with large sums of data in an efficient way? You cannot simply load 3 terabytes of data into your computer's memory. That's not going to work. How are you going to load it and pre-process it before you can pass it to something like a machine learning model? Now, quickly at this point, before I go further, I do want to mention that if you want to get good at these topics, it's extremely important that you apply everything that you're learning. When I was breaking into this field, I worked with tons of exercises, mini projects. It was making sure to constantly apply my knowledge, and that allowed me to learn this relatively quickly. Now, that's honestly why I've been working with and recommending DataCamp for years now. Their hands-on approach and interactive exercises makes a massive difference when it comes to learning topics like machine learning, and they have fantastic courses that I've used myself that are a great way to really get up to speed quickly. Now, DataCamp's Machine Learning Fundamentals in Python course is definitely the best one to start with if you're just getting into machine learning and you don't have a lot of experience. You go from working with supervised learning to unsupervised learning to getting into deep learning with PyTorch, as well as even looking at reinforcement learning before starting to get into some real machine learning projects where you can actually apply your skills. If you want to go to the next level, then I suggest having a look at the Machine Learning Engineer course. This one covers similar topics, but also gets into things like MLOps, introduction to shell and bash commands like I was talking about before, and working with predictive modeling for things like agriculture in the real world projects that you dive into. And then lastly, if you really want to go to the next level, they have the Machine Learning Scientist course, which again has some similar topics we saw before, but also gets into things like clustering, linear regression, and classifiers, and has again more projects so you can actually understand and apply all of this knowledge. Overall, DataCamp is a fantastic platform. I've been working with them for years now, and you can get 25% off all of their courses by clicking the link in the description. Thanks to DataCamp. Let's get back into it. So once you've mastered handling and working with data, it's time to actually start diving into some real machine learning algorithms. I have a long list, so I'm just going to read them from my computer and we'll put them up on screen. So first, I recommend looking into regression algorithms, specifically linear regression, regularization, so things like ridge, elastic net, and then looking at the metrics of regression like MSE, RMSE, and MAE. If you don't know what those mean, don't worry, you can look them up. Next, we have classification, essentially doing things like binary classification. Is it black? Is it white? Is it a dog? Is it a cat? And looking at things like logistic regression, naive Bayes, decision trees, and then the various metrics for these models like F1, the precision or the recall, and then ROC-AUC. After that, I recommend looking at ensemble methods, so things like random forest and then gradient boosting. These are actually methods that are commonly used in various Kaggle competitions, and there's a reason for that. I also suggest looking into clustering, so k-means clustering as well as k-nearest neighbors, then looking at support vector machines or SVMs and understanding things like kernels and high-dimensional feature spaces. That is going to cover most of your core machine learning algorithms. I suggest actually understanding the math behind these algorithms and not just simply using them. And while you don't need to be a mathematician, looking at how they're built and why they work the way they do gives you a deeper understanding that I know when I was learning I found extremely valuable. Okay, now after you learn your core, and these are kind of the basic simple machine learning algorithms, you can start looking into something that is objectively a little bit more exciting, which is deep learning. Now, deep learning involves things like neural networks, and within deep learning, you have a few frameworks you can choose. So you can go with either PyTorch or TensorFlow. It doesn't really matter which one you pick. PyTorch is kind of the Facebook Meta side of things. TensorFlow is supported by Google. And again, they're very similar in terms of the way that they actually work. Regardless of which one you decide to go with, I suggest learning the following skills. So building a feed-forward neural network, then looking at convolutional neural networks, recurrent neural networks, and other neural network architectures in terms of the layers, the nodes, the activation functions, and all of the other components that make up a neural network. I also recommend looking into backpropagation and understanding how a neural network is actually trained. Also understanding loss functions and optimization, which gets into some basic linear algebra, which again is good to understand. Also looking at regularization techniques, so things like dropout or weight decaying. Then transfer learning. This is essentially when you take an existing model and transfer its knowledge, but add existing data or parameters to it to kind of fine tune it. And then this kind of gets into the same thing, fine tuning pre-trained networks. So again, using something that's already been trained on probably billions of different data points, and then adding your own data to it to make it more customized to your particular task. In terms of some specialized areas you could get into within deep learning, you can look at computer vision, for example, with things like convolutional neural networks. You can look at NLP or natural language processing, same thing, using a neural network, things like time series forecasting or recommendation systems. There's a whole world to dive into here, but neural networks are extremely interesting and you should get a lot of experience building tons of them in many different areas. Now, once you've gotten good at neural networks and you've built a few projects and you really understand how they work and applied it to your own data, I suggest looking into reinforcement learning. Now, this is going to include things like Q tables, the Markov decision processes, value iteration, policy gradients, things like PPO, A3Q. I'm just reading some of the things that I have in my notes here. And reinforcement learning is an interesting technique of training because you essentially allow the model to explore and to reinforce what it's learned based on how it kind of explores. So a great example of reinforcement learning is training an AI how to play a video game. You can actually just throw the AI in the video game, give it a bunch of outputs like moving forward, jumping, left, right, and based on the action it takes, it can get some kind of reward. So if it reaches the end of the level, it gets a really large reward. If it falls off the map, it gets a small reward. This is reinforcing a certain behavior, and the model can learn, depending on how you've set this up, how to actually achieve the desired result based on the rewards and the incentives that you've set up. A great example of this is actually something like a Flappy Bird AI that I built many, many years ago that uses reinforcement learning so that the model can understand when it should jump versus when it shouldn't jump to get through the pipes, right? It gets a reward if it gets through the pipe, it gets a negative reward if it dies, and just simply by doing that, it's able to figure out the correlation between what it sees on screen and what action it should take. So that is reinforcement learning, and the next topic on my list is LLMs. Now, of course, we're in kind of the AI era now, and while machine learning is not the exact same as AI, there is some crossover, and it is important to understand LLMs if you want to be a machine learning engineer. So for example, you should understand tokenization, embeddings, attention mechanisms, the transformers architecture, and overall how an LLM actually works. And in practice, you should understand how to build things like RAG systems, retrieval augmented generation, how to fine-tune LLMs using something like the LoRa adapters or those kind of methods, how to use vector databases for quick lookups, and then how to serve models efficiently using web servers like FastAPI or Flask. A lot of times when you deal with these LLMs, you're not building them from scratch, you're simply integrating them into an existing software system, and that's where you want to focus your efforts and your understanding. So even things like prompt engineering, providing tools to models and building agentic workflows, and things like caching and cost monitoring and optimization for these LLMs so that they don't get extremely expensive. But none of it matters if you don't have this last topic on my list, which is MLOps or machine learning operations. Now, you can have the best model in the world, but if no one's able to use it, it doesn't really matter. So that's why the last topic on my list is MLOps, which has to deal with the actual deployment and use of these ML models in a real world situation. So again, I have a lot of topics. Let me list them off to you. For example, Docker, you need to understand that, and containerization, Kubernetes, CI and CD, so things like GitHub Actions, automatically deploying and testing your ML models, things like various model registries, so like MLflow, SageMaker, Hugging Face, things like feature stores, so for example, Tecton or Feast, experiment tracking, so the different weights and biases, and then various other concepts like model versioning, reproducibility, data versioning, model serving. Again, we talked about that, like a Triton inference server, fast API, things like A/B testing, canary deployments, and then of course monitoring and logging these models. Now this typically is going to be in the form of something like a data pipeline, and there's all kinds of other topics that I'm honestly not the best person to discuss because I'm not an expert machine learning engineer, but the more you can learn about MLOps and deploying these models in a real world situation, the better off you will be and the more senior you will come across as an ML engineer. Again, a lot of times as a machine learning engineer, a minority of your job is actually working with ML models. A majority of it is doing legitimate software engineering work to support the machine learning models that already exist. It's not always building the next crazy neural network. It's usually how do we actually deploy this out and get real customers to use it in an efficient manner. And that's why there's so much focus on this particular section. So with that said, guys, that is everything I had for you in this video. If you enjoyed, make sure to leave a like, subscribe to the channel, and good luck on your machine learning journey.